In this video, we are going to explore what is meant by polarization ellipse and axial ratio. So before going into the details, let's have a quick recap on the elliptical polarization. So elliptical polarization means if tip of the electric field is having a locus of ellipse, it is known as elliptical polarization, and these are the conditions of the elliptical polarization. That means it should have two orthogonal components, and these must have different magnitude, and the time difference uh, between these two components is not an integer multiple of 90 degrees. So these are the conditions to obtain the electrical polarization. So we saw in our elliptical polarization video that the polarization, linear polarization and circular polarization can be considered as special cases of elliptical polarization by substituting different conditions for delta and Ex and Ey zero components. We will get linear polarization and circular polarization from elliptical polarization. So based on this idea, as the elliptical polarization is the basis of linear and circular polarization, polarization ellipse is defined. So polarization ellipse is a geometrical description of how the tip of the electric field wave move over the time at a fixed space. So it is similar to, it represents how the polarization of the electric field is changing. So it is a general way to describe any polarized wave, linear, circular or elliptical polarized wave. And this is plotted on a plane perpendicular to the direction of wave propagation. So in this case, we are considering our direction of propagation is along z axis. So substituting all these conditions, this is the equations that we are getting for this ellipse. So based on different values, we will be having different shapes of the ellipse. So this is the polarization ellipse, which describes about the orientation of the electric field. And this is the equation of the polarization ellipse. So this is the basic structure of the polarization ellipse. It has a major axis which represents the maximum instantaneous amplitude of the electric field, and it has the minor axis which represents the minimum instantaneous amplitude of the electric field, and we have the tau which represents the tilt or orientation. This defines the physical orientation of the electric field with respect to the reference axis, and the rotation sense, which gives an indication about whether this wave is right-handed or left-handed. And next is axial ratio. So axial ratio is the fundamental parameter which is used to describe the shape of this polarization ellipse. We know that the polarization ellipse has the major axis and the minor axis. So the ratio of this major axis to the minor axis is known as the axial ratio. So it can be given by means sorry, this is not in dB, this is the linear scale. So axial ratio in linear scale is OA by OB, or it can be given by the major magnitude of the electric field to the minimum magnitude of the electric field. So it gives an indication about whether this wave is linearly polarized, circularly polarized, or elliptically polarized. So this value is a dimensionless value, and its value is always greater than 1. So these are the axial ratio values for different polarization. So in case of a circular polarization, we know that both x component and y components are same. That means that both major and minor components will be equal. So the axial ratio will be equal to 1. In case of linear polarization, we know that it will be having only one component or the slanting components. So the minor component in this case is 0. So that axial ratio will become infinity. In case of elliptical polarization, we know that the major component is more than the minor component. So it will result in axial ratio greater than 1. So sorry, this is just axial ratio, not in dB. This is the linear scale. So if you want to convert this axial ratio from the linear scale to dB scale, you have to convert using 20 log of AR, and in case of the circular polarization, it will be 0 dB, And in practical case, it is considered that if axial ratio is less than or equal to 3 dB, it can be considered as circularly polarized case. And in case of elliptical polarization, the axial ratio is greater than 0 dB. Practical cases, axial ratio greater than 3 dB to be considered as not CP, elliptically polarized here. And in case of linear polarization, the axial ratio is equal to infinity. So these are the conditions for the axial ratio for different polarization. Sorry for this mistake. This is the axial ratio in linear scale, not in dB scale. I hope you get some idea about what is meant by axial ratio. Thank you for your support.